Welcome to this video session on RDBMS versus different types of NoSQL databases and when to use which kind of database. At the outset, I want to stress on two things. Number one, this video session is not for the experts because it contains basic and intermediary level of information. So that is why I would say this video is more for the junior programmers or the college students who are still struggling to understand the different types of NoSQL databases and when to use which one. And second is my assurance or my promise would be if you stay along with me for the entire duration of this video, I think you should be in a position to actually make the right decision for what kind of NoSQL database or RDBMS you should use for your given requirement. So with that said, I'm Shomik, a software engineer who would be presenting this video to you. Let's get started. So over the time, what I have realized is NoSQLs are actually a natural evolution in response to the needs of the modern software system where we need to store a huge amount of data and also a huge amount of unstructured data. What I've also realized is it's not about that RDBMS is good or NoSQL is bad or NoSQL is good, it's RDBMS is bad and RDBMS is obsolete. It's not that. RDBMS has been around for, I think, last 30 years and in my opinion, it would be around for also years to come. But there have been really some interesting NoSQL databases which have been developed over the last 5 to 10 years, which are much leaner or compact solution to the exact problem that the modern software systems have. So in order to understand that in more detail, let us first try to understand what a distributed database means. So if you're not accustomed with the topic of distributed database is just like a distributed system, which means the data is actually, or the database actually consists of multiple databases which are spread across the network, actually spread across the entire world, you can say. So as you can see in the diagram, that there are multiple databases like database 1, maybe that is in Europe, but database 2, maybe that is in Asia, database 3, maybe that is in North America, database 4, maybe that is in South America, just like that. They are spread. So the different components of the same database are actually spread across the entire world. So the data is actually split and replicated into multiple instances for better availability, for better scalability. So this is a very high level overview of distributed databases. Different distributed databases have variations of this architecture, but this is a very high level overview. Now, what is important to understand from this high level overview and what is applicable for most distributed databases is the fact that out of these different nodes or out of these different individual databases, some accept write where the data is written and some are basically read replicas from where we read the data. So one thing which we need to understand very clearly before we go further is when data is read from a node, like when we are trying to read data from any of the read nodes, like say for example we are trying to read data from sixth node here, we can choose from either of the options. Either we can choose to have the latest data, which means consistency, or we can choose to have a faster response time, which means lower latency. So what we always need to understand is in the concept of a distributed database, consistency and latency are kind of trade-off. We cannot actually have both because the data takes some time to actually spread from the written node to the read node. So that is why if we want to get the latest data, we have to sacrifice latency. So if we have to get consistency, we'll have to sacrifice latency and vice versa. So with that said, let us understand what is this PAC-ELC theorem about. So you might have heard about the CAP theorem. PAC-ELC theorem is a modern version of the CAP theorem which extends the CAP theorem. So what it essentially states is there can be two scenarios. In the normal situation, like what we saw in the previous slide, any data, when we are interacting with a distributed database, we have to choose between latency and consistency, which means we have to choose between performance or correctness of data. And in the second scenario, when there is a network failure, then we have to choose between consistency and availability itself, which means we have to choose between correct data or whether we are at all getting a response. So, friends, since this is actually a distributed database, as you can understand, or rather, I would say that this is the age of the distributed database. So, we have to understand that whatever we are getting comes at some cost. So that is why what we are talking about in PAC ELC theorem is basically a trade-off. In a normal situation, we have to do a trade-off between latency and consistency, and in a network failure, we have to do a trade-off between availability and consistency. This is kind of fundamental to understand all distributed database. And if you understand this, then you will basically understand how every single distributed database actually capitalizes, uh, mm, or rather stresses on one of the aspects. Okay, so let's move on and let's look at some of the major types of distributed database, or rather NoSQL distributed databases, and when should you use which. So the key value store. Key value store are like the simplest of the NoSQL databases, NoSQL distributed database. They are normally in-memory distributed databases, and hence both writes and reads are much faster. So the first question is, why should I use a key value store above RDBMS? Uh, the answer is, when you just need to store some key value pair and only for a temporary period of time, like you want to cache some data, maybe that is some kind of reference data like country list, currency list, or maybe that can also be customer data, but which is only temporary and which is only applicable for caching, and we do not need to store that data permanently, then we can actually choose a key value store. Examples include Redis, Hazelcast, Memcache, and many others. So what is the advantage of key value store? It is a cheaper solution. It is a cheaper and faster solution than RDBMS if you just want to cache data temporarily. Of course, it cannot replace RDBMS when you need to store the data and there is a huge relationship between the data. Moving on, the next type of NoSQL databases is the document database, and I would say that they come closest to the RDBMS, with the with one of the major difference being that the document databases do not have a fixed schema. So you can actually start inserting data into the table before actually creating the table itself. And that is why that normally, if the insert load is very high, then we normally opt for document databases. Example of document databases are MongoDB and CouchDB. And why we opt for why the inserts are much faster in document databases than RDBMS? Simply because during the insert, the schema does not need to be validated, unlike RDBMS. Again, it's not that RDBMS is bad and document databases are better. It's only the fact that if your schema kind of evolves over time, and if you do not know what would be your future schema, and also if you have a very high write load, then maybe you can look at using a document database than using RDBMS. Moving on to the next type of NoSQL database, which is known as a columnar database or a column-oriented database. Now, this is a very big topic, and I will, of course, within this presentation, we do not have the scope to go into the details of it, but at a high level, this is also another kind of, this is also similar to RDBMS, with the difference being, with the difference being, then this kind of databases stores contiguous columns together, and also normally they support very high write load, and also they do not support that level of relationship. So the next question which comes is, when should I use a column oriented database? We should use a column oriented database normally. So there are a couple of specific scenarios. So if you have a data analytics scenario, like we need to do some aggregate of specific columns, then and there are and a lot of rows are there, then a column-oriented database would be much easier because, as I mentioned, that it stores the data of contiguous columns together. Then it will be much faster than the row-oriented databases or our normal RDBMS. Also, if we have a very high insert load, but the data is not very relational, which means there are not much relations between data, but uh, we have a high insert load, then also we can probably think of a column-oriented database than RDBMS. Again, friends, it's not about RDBMS is obsolete and column-oriented database is bad. If we have a high degree of relationship and the volume of the data is not too much, then RDBMS is still a better solution. But if we have a huge volume of data which does not have a lot of relationship, and also if we want to make queries on specific columns, like we want to see max of a column or we want to see mean or average of a column, then column-oriented database is a better solution or an easier solution than RDBMS. Then moving on to the next type of NoSQL databases is the graph databases. So this is another niche area where this is rather another very specific kind of database, and it is particularly useful when we are, say, for example, designing the backend or designing the data store of a networking site, of a professional networking site, or a friendly networking site. So ideally, if we have, say, multiple degrees of relation, like, say, for example, in any kind of networking site, we would have uh, friends of friends of friends, connections of connections of connections. So if we want to retrieve this level of relations, like three order or fourth order relation, like friends of friends of friends, or connections connections order, then the retrievals are much faster in a graph than in RDBMS because of the way the data is stored. And again, it's not RDBMS versus no versus graph database. Graph databases shine in this specific use case when there are several degrees of relation and we want to retrieve data faster. And examples include Neo4j, that's one of the most used example of the graph database. Moving on, time series database. So time series database is another type of NoSQL database, which is rather simple, I would say, and ideal for storing time series data like weather recording, sensor data, etc. So again, this is a very specific use case, and if you have the need to store time series data, then this is a leaner or a cleaner solution than using an RDBMS. Next type of database is the text search engines. You might have already heard about text search engine like Elasticsearch or Solr. So they are basically inverted index and ideal for text search. In today's world, the needs of the modern software systems, we have a lot of text search. So these databases, these text search engines are actually perfect for doing text search because they are much faster than RDBMS uh, for text search. But it is not so ideal for relational data. Again, as you can see here, that this also has a very specific use case, but of course, RDBMS also has its own use case. So these were the main types of NoSQL databases that we already have seen. And as you can understand, as you have probably now understood, that mm, it's not that RDBMS has become obsolete. It's that for very specific scenarios, like if you want to do caching, go for a p-value store. If you want to, if you do not know how your schema will evolve over time, then probably go for a document-oriented database. If there are analytical queries, or if if you want a really fast insert load of a huge volume of data, then go for a column-oriented database. Graph database is ideal if you have a if you're designing the data store for a networking site, and uh, search engines are ideal for text search. So let us see what we sometimes do in modern software systems in today's world. We often use the word polyglot persistence, which means we use multiple databases to actually achieve our goal. And here is a very common pattern that I have seen. Like, we are using two kinds of databases. So as you can see in the diagram below, so first we ingest the data in either a document-oriented database or a column-oriented database, because the data ingestion rate is much faster there compared to RDBMS. And then we do an async replication to either an RDBMS or a text search engine like Solr, and from there we can do a data retrieval. Now, on top of the RDBMS or Solr, we can also have a cache engine if we want to, cache engine, which is basically a key value store, if we want to actually uh, cache some data. So this type of concept is often known as CQRS design pattern. Basically, a type of CQRS design pattern, command query responsibility segregation. So we are basically segregating the command and the query pattern, and we are using two tools which are best for their own job. And please keep this in mind, and probably you can reuse this architecture in your own use cases. That said, we have come to an end of this video. I hope all of you have enjoyed and have been able to get some essence out of this video. And if it is so, I would like to humbly request all of you to like this video and to also subscribe to my channel and share this video link with other friends who you think will also benefit from this, because that would definitely motivate me further to create more useful content. Thank you very much.